All right, so that first one, the triangle system, remember the process that we use is back substitution. You're going to hear that word a lot when we get to matrices, but it means take the bottom one, plug it into the one that has two variables. So 2y minus 3 would equal 7, 2y would equal 10, y equals 5. And then take the z and the y and plug it back into the original. So 3 times x plus 5 plus 2 times 3 equals 8. 3x plus 5 plus 6 equals 8. 3x plus 11 equals 8. 3x equals negative 3, and x equals negative 1. And then remember, we put it in coordinate point form, negative 1, 5, and 3, just like that. So on Canvas, you'll type these answers in. Again, no spaces. Questions on that one? All right, number 2. So I'm going to number these 1, 2, 3. And somebody walk me through their process.
I grabbed 1 and 3.
Okay, 1 and 3 to cancel what?
X.
Cancel the x. So you did 1 times 2?
Yeah.
2 times number 1, and then 3. So 2x plus 4y minus 2z equals 6. Negative 2x minus y minus 3z equals 8. These cancel. 3y minus 5z equals 14. And that's new 1. Okay, then you have to use 2.
And I used 1 in that one.
And you multiply by negative 3?
Yes.
Okay. Negative 3 times 1. So 2 is 3x plus 7y minus 5z equals 14. And negative 3x minus 6y plus 3z equals negative 9. Cancels. Y minus 2z equals 5. New 2. So you could have done it differently, but at this point you should still be down to 2 equations with 2 variables. Then we're going to do new 1 and new 2.
And I solved for z, so I did times negative 3.
So we did the bottom by negative 3, and by we, I mean you. Negative 3y plus 6z equals negative 15. Bring down the 3y minus 5z equals 14. And there's our first variable. Then you have to take that and plug it into one of the new ones. So which one did you do?
I did the easy one.
New 2?
Y minus 2z.
Yeah, okay. Y minus 2z equals 5. Y minus 2 times negative 1 equals 5. There's the y. And then you have to plug it into one of the original.
I used 1.
The top one, yeah. X plus 2y minus z equals 3. So x plus 2 times 3 minus a negative 1 equals 3. X plus 6 plus 1 equals 3. And x equals negative 4. Thank you. Good job.
So much Chris Levy.
Yeah.
I keep making like this silly mistake.
So stop doing that.
I know. When you have them lined up, like your new 1, for example.
Yeah.
Are you always adding them unless the negative sign is there?
So you're always adding them.
Okay.
Always adding, which is why if they're both positive, we change one to be negative so it cancels out.
Okay.
So the minus of a negative is where people make mistakes. So I always say change it and add it.
Okay.
Yeah.
So always add.
Yep, always add.
Thank you.
You're welcome. Any questions on what we talked about yesterday? So what we talked about today is actually very different. There's a way to do it with systems of equations, but there's a way to do it without, and it's very different. But it's called...
Thank you.
Oh, you're welcome. Oh. And then what'd you do from here? Did you cancel out the z's or the x's?
Follow my word.
Mm-hmm.
What was X in the warm-up? Oh, I did the Z.
X in the warm-up is negative 4. You did the z's?
Yeah.
So did you do the negative in the top or the bottom?
On the top.
So negative 8 and positive 9?
Yes.
So negative 48, negative 72, 38 times 8, negative 312, 306x, 72z, 1215. And then divide it. So what are they both divisible by? 7, yeah. Nope. They're both divisible by 129. That's horrible. Yep. No. What?
Yeah, I got some weird number for this one, so I just figured it was 1 because you said that you'd never get it.
No, it ended up simplifying to 7 over 2, but that's not 128. The heck?
Yeah, I already messed up at the top, so I didn't get 903, but.
This should be 896. That's what I'm trying to find where I went wrong there. The thing with and that's what's hard with the web assigning the big, sometimes you're going to get big numbers through it. Your answers may not be that big. But it should have been 7 over 2 for the x, and then you take it, plug it back in, it should have been negative 9 over 2, and then it should have been 2. So had we known, honestly, I probably, just because it got ugly after the y, and that's what I was talking about yesterday, it might be smarter to pick the z's, because I can pick this one with this one and only have to change one, and then I can pick this one with this one and only have to change one. Does that make sense? Or even this one with this one. You want to kind of plan ahead. So I know that these are going to cancel once, but then the next time around, I'm going to have to pick this with one of those, which means I have to change both. Does that make sense? Yeah. So you want to try to plan. The same thing would happen with the x's, right? There's 2 3s, so I could change one sign, it's going to cancel out. But when I go to do it with the other one, I'm going to have to change both the 3 and the 5. So the z's were the one that if I actually picked right, I would have only had to change one both times. Does that make sense? Yeah, okay. All right, so we're going to talk about fraction decomposition. So we're going to do part 2 of this, which is called partial fractions. Okay, which is not something you've been exposed to before. Obviously, systems you've been exposed to before many times. But for these partial fractions, we haven't. This is something that, when we were pressed for time a couple times, I'll ask, Miss Boyd's the one that I feed into, right? That's where you go next, most of you. So I'm always can I skip partial fractions? And she's like, absolutely not. They need it. I'm like, dang it. So there's a lot of things like that. So partial fractions, the idea behind partial fractions is instead of, we're used to taking the right side of this equation and combining it to get the left side of this equation, right? Up to this point, we would have not necessarily in the last chapter, but you're used to, I have 2 fractions. In order to add them together, I got to find a like denominator and then combine them, right? That's our normal progression. Decompose means the opposite. So we're doing the opposite. So we're taking something that is already combined and we are breaking it down into its parts, which is what the partial fraction decomposition is, okay? So the method to doing this is really not that bad. I'm going to teach it to you. And again, if you pay attention, I promise, and you practice it, it's the same process over and over again. So it's not that bad. It's just that it's foreign to you. So the first one, take a deep breath. We'll walk through it, okay? And then when we get to the end of today, you'll see that hardest of these is the repeated factors, which again, we'll talk about when we get there. So when you start with partial fraction decomposition, okay, I'm going to skip all the nonsense at the top, and I'm going to come down to the bottom here. The first thing you're going to do is you're going to take your denominators, if they're not already factored, and you're going to factor them. So on this example, they're already factored, right? I have 3, and they have to be linear, so they can't be raised to an exponent. That's how you know to factor. These are 3 linear factors. For each linear factor, you're going to set up an equation, a fraction on the other side of the equal sign. So there's 3 linear factors there, which means I set up 3 fractions on the other side. And I separate them out by their denominator. Order doesn't really matter because you could factor in a different order than I do, as long as both of the factors are there. And then for each factor that is there, it gets a constant letter, which we say A, B, C. If there was 4, it'd be D, and you would go on and so forth, okay? And then we're going to learn how to fill those letters in for actual numbers. So we start by just the factoring and the splitting up, but then I'm going to teach you how to find those numbers. So this is the beginning. Just factor the denominator, split the fractions for each term in the denominator, and give the numerators A, B, C, and so forth for each fraction, separating it with a plus. Because we're decomposing, it doesn't mean you're dividing, it means you're breaking it down into a sum. Is there something for you to fill in on this line? I can't remember. No. Okay, good. All right, so they'll look like this. Now, pay attention to the directions because this says, write the form of the partial fraction decomposition of the rational expression. Do not solve for the constants, which means our answers are going to have the A, the B, the C, but eventually that's going to change. So if I look at the denominator of A, can I factor it? Yes. What can I do? Good. Take out an X, and I get X times X minus 4. Is that factored completely? Yes. There are 2 linear factors there, X and X minus 4. So I put 1 with the denominator of X, 1 with the denominator of X minus 4. Numerator of the first is A, numerator of the second is B, and then put a plus between them. And again, in a moment, we're going to figure out how to find A and B. But for right now, we are not solving for those constants. We're leaving them as they are. Look at B. Is B in factored form? The denominator? Yeah, it's already factored. So even though there's a squared there, it's already factored. So I get A over one of the factors, which is X, and then B over the other factor, which is X squared plus 3. Questions on that? Okay, now we're going to go past step 3. So step 1, 2, and 3 are the same. Factor the denominator, split the fractions for each term in the denominator, give the numerator A, B, C. Then we're going to take the initial expression on the left-hand side, and we're going to take A, and we're going to multiply A times whatever is missing from the denominator of A. And then we're going to go to B, and we're going to multiply whatever is missing from the denominator of B, and then so on and so forth. And then we are going to, one at a time, cancel out our constants, leaving us with just what remains, one constant. We'll solve for it. We'll repeat that process to cancel out the next one, and we'll continue, okay? Way easier to see than to read, so I'm just going to work it out. All right, so find the partial fraction decomposition of 6x plus 14 over x minus 3 and x plus 5. First thing is my denominator factored? Yes. Split it. So it would be A over x minus 3 plus B over x plus 5. We're good on that step, yes? Now we are comparing each fraction to the factored form on the left. So if I look at the A fraction and I go to the bottom, what is missing from x minus 3 to x minus 3 times x plus 5?
X plus 5.
X plus 5. So normally, in order to make this a fraction, I would have to multiply it times both the top and the bottom. And then I would go to B. What's missing from B? X minus 3. I'm going to do that on the top, and I'm going to do that on the bottom. Now what has happened is all the denominators are the same, right? So I'm actually going to completely ignore the denominator moving forward and only focus on my numerators until I get to the answer. So if all the denominators are the same, it's okay to also set all the numerators equal to each other. So I'm going to rewrite that with just the numerators. X plus 14, or 6x plus 14 equals A times x plus 5 plus B times x minus 3. I'm even eventually going to skip the step in which I multiply it times the bottom because I don't need it. Technically, that's what we're doing. We're multiplying the top and the bottom by the same thing, but we don't have to write it out every single time because it's the same thing every single time. So again, I only grab the numerators. Now, there are two constants, an a and a b, so I want to solve once to cancel out the a, and I want to solve once to cancel out the b. So what number could I plug in for x that would cancel out my a? How would I get rid of a number?
You make it 0.
I'd have to multiply by 0. So how do I make x plus 5 0?
Great question.
What could I plug in for x? Negative 5. Yeah? We see that? Yeah? So first thing I'm going to do is plug in negative 5. It's going to cancel out the a. And then what would I plug in to cancel out the b? Positive 3. The other way you know those is you take your denominator that's on the left and you set it equal to 0 for both those, solve it, and it'll cancel it out. Does that make sense? It doesn't matter in which order I do it. I can cancel out b first and a. It doesn't matter as long as I get both at the end. So now I'm going to use this, and everywhere there's an x, I'm going to put negative 5. So 6 times negative 5 plus 14 equals a, negative 5 plus 5 plus b, negative 5 minus 3. I work out what's on the left. Negative 30 plus 14 would equal a times 0 plus b times negative 8. Negative 16 would equal a times 0 is gone. B times negative 8. And then how do I solve for b? Divide both sides by negative 8. And b is 2. With me so far? Now I repeat that process to cancel out b. So I'm going to take that whole big 6x plus 14, that whole thing, and I'm going to plug in 3 to the x. 6 times 3 plus 14 equals a times 3 plus 5 plus b times 3 minus 3. So 18 plus 14 equals a times 8 plus b times 0. 32 equals a times 8. And this is gone. Divide both sides by 8. And a is 4. Now my answer is the decomposed fraction. So I come back up here and I plug in the a and I plug in the b. So the a, which is 4, goes over x minus 3. And the b, which is 2, goes over x plus 5. Santi, you getting all this? I'm making a smirk behind my mask, just so you know, because I know that you're not doing it.
This feels like it needs to be its own chapter.
I promise you it speeds up. Because once you get to know what you're doing, you're like, oh, that's going to be 0, that's gone. You move a little bit faster through it. The first one's always the worst.
It's like, oh, there's more.
It's like you're speaking another language. We still breathing?
Yeah.
Yeah, okay, good.
Just that, whatever it was.
Yeah, the 4 over the x minus 3 plus 2 over the x plus 5. Yep. All right, next one.
So for that one, our answer is
All right, so what's step 1? See if it's factored. Is it factored? Yes. So then I get a over x minus 2 plus b over x minus 5. What would I have to multiply a by? X minus 5. What do I have to multiply b by? X minus 2. And remember, technically, we should be multiplying the top and the bottom, but we're going to ignore that second step because it would go away anyways. Now we grab the numerators. X minus 14 equals a, x minus 5, plus b, x minus 2. What are the two x values I'm going to plug in? Positive 2, positive 5. So 2 minus 14 equals A times 2 minus 5 plus B. 2 minus 2, negative 12. A times negative 3. This would be 0, and this would be gone. A is 4. Then repeat it with 5. 5 minus 4 equals A. 5 minus 5 plus B. 5 minus 2. Negative 9 equals, this would be 0, that would be gone. B times 3. Divide by 3. And B is negative 3. So my answer is, remember this, with my A and my B plugged in. So 4 over x minus 2 plus a negative 3 over x minus 5. And we don't normally see the negative on the numerator. So when there's a minus, we pull it to the middle. So this is 4 over x minus 2 minus 3 over x minus 5. So if the numerator has a leading negative, we pull it out. We make it the minus in between.
But then when you make x plus 5 instead of x minus
No, because just the numerator is negative, so we need it to be negative. If we did negative and negative, it would make it go above positive. So the great thing, again, about these is with extra time, and I say that like with not a lot of faith that you're going to have extra time, but if you had extra time, you could check it. You could actually work backwards. So I could say, what would be my least common denominator? It'd be x minus 2 and x minus 5. I'd have to multiply 4 times x minus 5. I'd have to multiply 5 times x minus 2. Combine them together, and I'm going to get my question. So you can always work backwards to check these. Still with me? Yeah? Okay, again, step 1, check to see if the bottom is factored, is it? No, this time we got to do some work on the denominator. So how do I factor x to the third minus 4x?
Pull the x out.
Good, take the x out. Now is it factored? Nope, I got to do one more thing. Difference of 2 squares. So how many fractions are we going to have? Yay! So we get A over x, B over x plus 2, C over x minus 2. There are two kinds of people in this world. People who factor difference of 2 squares to x plus 2, x minus 2, or x minus 2, x plus 2. And it doesn't matter which person you are. The order can be different. What matters is at the end, the right number goes over the right denominator. Okay, so now what would I have to multiply A by?
x squared.
X plus 2 and x minus 2, or x squared minus 4. You could do either one. But this is all 3, right? And this only has x. So I do x plus 2 and x minus 2.
I was thinking something else.
Okay. How about B? X and x minus 2. How about C? X. Good. And x plus 2.
Would it matter if we change, like, let's say we had x minus 2 under B and then x plus 2 under C, would that change it at all?
Nope.
No? Okay.
Yeah, no, it will not. It's just that when you get to the end, your numerators will also be in different order. But as long, when I get to the end, I'll tell you, like, as long as this number's over this and this number's over this, that's good. But the order there doesn't matter. Yeah. Okay, so now just my numerators. So x squared plus 12x plus 12 equals A times x plus 2 times x minus 2 plus B times x minus 2 plus C times x plus 2. Yay! It's like, okay, I finally understood the last example. Now let's make it harder. All right, so now I got to figure out what's going to cancel these out. And this is a scenario where it might be easier just to go back to your original factored denominator and set each of those terms equal to 0. So I know I'm going to end up plugging in a 0 to cancel out something, a -2 and a 2. So if you just set the denominators from the factored form, each equal to 0, those are the three numbers you're going to plug in for x. I think that's easier than saying, okay, how do I cancel out the a? Well, I could plug in a -2 or a +2. How do I cancel out the b? Well, I could plug in a 0 or a +2. How do I cancel out the c? I could do a 0 or a -2. So if you just go back to the factored form of your denominator and you solve each of those factors, those are the three numbers you're going to plug in for x. Does that make sense? According to your face right now, no.
No, it does.
Okay.
Why didn't we know about that earlier?
I did say it earlier. I did.
You did?
Mm-hmm. I said you could cancel it out or you go back to your factored form and set it equal to 0.
But then it has to want us to work it out. You don't want us to cheat sheet.
No, it's the same thing either way. I'm not done. Those aren't my numerators. Those are the numbers I have to plug in. Is that what you mean?
Keep going, Kristen.
Okay.
I'll just watch.
I have to do x equals 0. I have to do x equals -2. And I have to do x equals +2. Yay! 0 squared plus 12 times 0 plus 12 equals I'm going to have to write this teeny tiny. 0 plus 2, 0 minus 2. B, 0, 0. B was minus or plus? Minus 2. C, 0, and 0 plus 2. So everywhere there was an x, I put a 0. So gone, 12 equals a times 2 times -2. B times 0 times -2, gone. C times 0 times 2, gone. 12 equals a times -4, and a equals -3. That's 1. Now B, or -2. So everywhere there's an x, yeah.
Could you go back to the 0 one and miscalculate how big it's going to be?
That's okay, me too. You see, that's why I had to zoom all the way in. Sorry. All right, -2. So -2 squared plus 12 times -2 plus 12 equals, and this is where I get lazy. I'm going to do a -2 plus 2 here, and that's going to be 0, so I don't need the a. I'm going to do a -2 here. This one I keep. B, -2, -2 minus 2. I go to C. If I plugged in a -2 there, the C gets the 0. I don't need the C. So you can write those all out, especially in the beginning while you're getting to know things. I would encourage it. But like once you get to the end and you know that 2 of those are going to cancel out, figure out which 2, and then you don't have to write them. So 4 minus 24 plus 12 equals B, -2 times -4. This would be -20 plus 12, -8. B times 8, and B is -1. Then I repeat it with the 2. 2 squared plus 12 times 2 plus 12 equals, when I plug a 2 in here, the a is gone. I don't need the a. When I plug a 2 into b, the b is gone. I don't need the b. The c, which should make sense because that's the last one we haven't solved for, I need. So 4 plus 24 plus 12, c times 2 times 4, 28 plus 12, 40, and C is 5. So my answer is A, which is negative 3. The negative goes out front. Negative 3 over x. Plus B would be plus a negative 1, so the minus goes in between. 1 over x plus 2. Plus C plus 5 over x minus 2. So if you had, so like kind of piggybacking on Matt's question at the beginning, if you had switched the order and done x and then x minus 2 and x plus 2, then it should be negative 3 over x plus 5 over x minus 2 minus 1 over the x plus 2. So when I'm grading these, I'm looking to make sure that the negative 1 is over the x minus, or x plus 2, and the 5 is over the x minus 2, and the order doesn't matter in my initial fraction.
Just quick question.
Yeah?
Will we ever have no solution or odd
No.
numbers in this?
No.
Okay.
Yeah. So the reason why they do it in this section is because the other method to solving these is actually using a systems of equation. And the way it works, and we're going to have to use it for repeated factors, which I'm going to show you in a minute. But the way it works is you actually would take this whole thing and you would multiply it all the way out. So on the right hand side, this would be A times x squared minus 4 plus bx squared minus, I would distribute it to both, 2bx plus, distribute this, cx squared plus 2cx, this becomes ax squared minus 4a. And then you group all the x squared terms together and set it equal to the x squared on the other side. You group all the all the x to the first terms together and you set it equal to the 12x that's on the other side. And you group all the numbers that don't have a variable on it other than the a, b, c, and you set it equal to the constant. And you solve the system of equation. So that is why it's in this section. I teach it this way because I think it's easier, but when we get to repeated factors, you'll see that method, and if that works for you, then do it, okay? I'm never going to tell you have to do one way over the other. But that is another option. But that's why they teach it in this section, or why they group it in this section. All right. So those are repeated factors. What happens, and this is where it gets a little bit jazzier, is if there's a repeated factor, meaning like an x squared, right? X squared factored would be x times x. The same factor, repeated, thus the words repeated factor, okay? If I had x minus 1 squared in my denominator, this factors into x minus 1 and x minus 1. Those are repeated factors. You cannot simply just break those apart and say that this should be a over x minus 1 plus b over x minus 1. And think about why not. If I was to work this backwards, if I was to combine this into one fraction, what would my denominator be?
X minus 1 squared.
What's your least common denominator of x minus 1 and x minus 1?
X minus 1.
Just x minus 1. So you wouldn't get the repeated factor. Does this make sense? So if I had, I appreciate the honesty. So if I had 2 over x squared, right? And I break that down to a over x plus b over x, because that's what factored this would be, right? This. And then I said if this was, I don't even know, I'm making up numbers, but say this is 3 and this is 4, and I said give me one fraction here. The least common denominator would be what? What's the least common multiple of x and x? Just x. But my fraction that they gave me should be x squared. Do you see that those aren't the same things? Just understand you can't do it that way.
Okay.
You can't. You can't just do it the way we've done it. So the way you do a repeated factor is you take that factor and one of the denominators gets it to the first and the other denominator gets it to the second. So you work your way up. So if it was just this, if I just had 2x, not 2x because that wouldn't work. If I had 2x plus 1 over x squared, then it's going to be a over x to the first and b over x to the second. So I have to have that factor to the first power and then that factor to the second power. If it was to the third, I'd have to, again, have it to the third power.
But then why did in the last problem there wasn't adding the extra x?
Because there was no repeated factor. We had x to the first, we had x plus 2, and we had x minus 3. Those are 3 unique factors.
Uh-huh.
This is x and x. That's a repeated factor. I'll show you in a second.
So
Look.
if it was x cubed, would you need a x to the third too?
Yeah.
So x squared, and x to the
Yeah.
third.
I won't do that to you, but yes, that's what you would need. All right, so let's look. This one just says don't solve, so we're just going to make it ABC for now, but we want to just figure out what it looks like. So I changed the exponent on that because the one you had was not a repeated factor and it defeats the whole purpose. So change A to x to the third minus 4x squared. Is that factored? No. How would I factor that?
X squared over x minus 4.
X squared times x minus 4. Is x squared factored?
Yes.
No.
Wait,
X
x
and
squared?
x
No,
squared.
it's not.
It's x minus 4 if I talk about a linear factor, right? Those are all three factors. Good morning. So when I rewrite this, it has to be a over x plus b over x squared. X is my repeated factor. Plus c over x minus 4. So x is my repeated factor this time. There are two x's, yes? X squared means there's two x's, yeah? So I can't just make it x. I can't just make it x squared. I have to make it x to the first and then x to the second.
It seems easier with, like, I put a 1 in the place of x, because x is just weird. So,
Put anything you want there, yeah.
I put a 1 just
To test it, yeah.
Does A have to be over the x? Can it be like A over x squared, or does it have to be in order?
No, it could be any order you want, but you have to have an x and you have to have an x squared. You can't have just the x squared. Yeah. So look at B. I got x, right? And then I'd get x squared plus 3 and x squared plus 3. That's my repeated factor now. So this would be a over x plus b over x squared plus 3 plus c over x squared plus 3 squared. So whichever factor repeats, you have to create a fraction with it over itself, and then itself raised to the highest power, which usually is squared, but you'd have to work your way up. All right, we're going to do this one. So the one I think that's on your, I'm going to go out of order because the one I had you open is different. Let's do this one because this is closer to what's like in the homework. So this says x plus 4 over x minus 3 squared. So my denominator factored would be x minus 3 and x minus 3. That is a repeated factor. Yes, we agree that that is the same thing written twice. So the first one gets a over x minus 3, and the second one gets b over x minus 3 squared. You with me so far? So here's the catch with these. If I do what we've been doing, what number would I be plugging in for x to cancel it out?
X minus 3.
You'd plug, so solve that. What would I plug in for x? 3. But if I plug in for x on this one, which needs an x minus 3, this one actually doesn't need anything because the denominator's already there. It's going to cancel them both out. So I cannot use that process on a repeated factor. It's not that bad, I promise. So I'm going to rewrite my numerators. X plus 4 equals a times x minus 3 plus b, right? And b didn't need anything because it already has x squared, or x minus 3 squared. So this is that systems of equation process. I distribute my a. And then I take the x. I set it equal to every term on the right-hand side that has an x, which is just a x. I take the constant on the left. I set it equal to everything on the right-hand side that doesn't have an x because we consider those constants. Now what can I do to the one on the left to solve for a? How do I get a by itself if it's in a multiplication statement?
Divide by x.
Divide by x. And x divided by x is what? 1. Now I'm using substitution because I know what a is. So I plug it into the second one. So you actually set up a systems of equation. It didn't look like it, but it is one. And it's a triangle system of equation. We had negative 3a plus b equals 4, and we had a equals 1. So we took the bottom number, we plugged it into the one with 2.
How
Taylor.
did you know how to split your x to your ax?
So if I had an x squared and an x and a constant, all the things on the right hand side that have an x squared get pushed over and grouped with the x squared from the other side of the equal sign. If I have x to the first, I ignore the ABC and I look at the x's. X squareds go with x squareds. X to the first goes with x to the first, and then ABCs go with the number. And then on the x squareds, you'll always be able to cancel out the x squared, and you'll only have numbers left. On the x to the first, you'll always be able to cancel out the x's, and you'll have the numbers left. And then you'll have one that you can solve. So I'll work through that last couple examples on the video, but I want you to try these. I'm going to tell you right now, I did not put repeated factors on your quiz because I want to practice them again on Monday, and I don't like to do it the day before. But you will have partial fractions on your quiz, okay? But there are questions at the end of the homework that are repeated factors. They're very similar to this, so I want you to be able to try them, okay? But don't get frustrated. One more thing is the format on WebAssign. If you have a fraction in your A, so if I had like 1 over 2 over x minus 3, it takes the numerator's fraction and it brings it down. So you take the 2 and you bring it down, 1 over 2 times x minus 3. So we've done that before. I don't remember when we had to do it, but we had to do it before. If you have a fraction in the top, you have to bring it down. But just realize WebAssign likes it like that. Okay? All right, folks. Have a great weekend. Take the time to look through. I released your your test feedback. I want to go over those on Monday, so please take the time. If you are an at-home person, remember that I graded your submission, so look at your submission for some feedback, and then compare it to your answers on Canvas. And then on Monday, I promise you that we'll spend some time going over that.
Thank you, Ms. Copeland.
You're very welcome. Have a fantastic weekend.
Thank you, Ms. Harris.
You're welcome, Maria. Sai, were you asking a question? Yeah. Like we did before, it goes back into your numerator. So A, this one. So A is 1 over x minus 3, and B is 7 over x minus 3 squared. So that's the answer it's looking for.
Okay.
Good?
Yeah.
Yeah, okay.
All right, thank you.
Bye, Sai. Have a great day. Okay, so in this example, we again have a repeated factor. So this would be x times x, which means it repeats. So when we write this out, we have to do a over x plus b over x squared plus c over that last one, which is x plus 1. So the a needs another x and the x plus 1. The b just needs the x plus 1. And the c needs the x squared. So it would be 4x squared plus 2x minus 1 equals ax times x, so ax squared, ax times 1 plus ax, plus b times x, and then b times 1, plus c times x squared. And we can't do the original method where we plug numbers in to cancel out because there's a repeated factor, which means I'm going to group together all the x squareds. So 4x squared would equal ax squared plus cx squared. I'm going to group together all the x's. So 2x would equal ax plus bx. And then the last remaining one, which is the constants, -1 and b. So I have a system. I can cancel through the x squareds here. They would all divide out, and I'd get 4 equals a plus c. Cancel through the x's here, and I'd get 2 equals a plus b. And -1 equals b. So I can take b, plug it into the second one. 2 equals a minus 1. A would equal 3. And then I can take a, plug it into the first one. 4 equals 3 plus c, and c equals 1. And then I've got all three. A, which is the 3, goes over the x. B, which is a -1, so -1 over the x squared. And c, which is 1 over x plus 1. And there's your decomposition of that initial fraction. Okay, last one. Again, repeated factor. So a over x, b over x squared, c over x plus 2. So a is missing the second x and the x plus 2. B is missing the x plus 2. And c is missing the x squared. So 9x squared plus 3x minus 1 equals, multiply this out, ax squared plus 2ax plus b times each of these, bx plus 2b plus cx squared. Group together all of your x squareds. 9x squared equals ax squared plus cx squared. Group together all of your x's. 3x, 2ax plus bx. And your constants. So b equals negative 1/2. From these, I can cancel through my x's and make b negative 1/2. So I can multiply by 2 here. This would be 6 equals 4a minus 1. Add the 1. Divide by 4. And the last one, I can cancel out all the x's. I don't know c, but I know a. I can multiply by 4. Subtract the 7. So now when I rewrite this, the a is 7/4 over x. The b, negative 1/2 over x squared. And the c, 29/4 over x plus 2. But remember, the fractions can't stay on the top, and the negative can't stay on the top. So this becomes 1/4 times x minus 1/2 x squared, 29/4 x plus 1, or x plus 2. You'll even see it sometimes they'll take out, if they all have the same number here, they'll take it out on the front, but because they're different here, you can leave this in. You just can't leave the fraction over the variable. All right, that wraps it up. Have a great day.